Hello guys, welcome to Basic Chemistry Plus, and today we are going to continue the States of Matter chapter. And in the last video I think you have watched it, and over there I talked about the different types of intermolecular forces, and I also told you that the intermolecular forces are the reason behind all the physical properties that they show. So if a molecule is showing higher boiling point or lower boiling point, that is all because of the intermolecular forces. Sometimes they can ask you about um, the state of matter, like why is water liquid and why is ammonia gas. So in these type of questions, like when they ask you anything related to physical uh, properties, that is going to come from the intermolecular forces. So there are 5 types of intermolecular forces, and I have talked about all of them in details in the last video. So if you haven't watched it, then please go to the video and watch the entire video before you start this video over here. So the link would be given in the description, so you would be able to get it from there. Now today we will be starting from the most important part of this chapter. In the very first video I have told you the pressure point, the pocket regions of this chapter, right, from where the questions are going to come in different types of competitive examinations. So today we are going to step into the first pocket region of this chapter, which are the different types of laws those are there. After that, in the next video, I'm going to solve the graphical questions. You know that if you just go through the previous year question papers of CBSE, let's say JE, and whatever the exam is, if you go through it, most of the questions from these laws are coming in terms of the graphs. So they would be giving you a graph and they would be asking you questions from there. So these graphical questions are the type of questions I think all of you struggle with. So I am going to solve those graphical questions in the next video. So don't forget to subscribe to my channel. Now, today we will start with the 3 important laws of the states of matter. And before we talk about that, let me tell you, there are 3 measurable properties of a gas. If I am talking about a gas, for a gas there are 3 measurable properties. Mainly, one is pressure, and the other one is volume, and the other one is temperature. You may add one more thing in these measurable properties, which is the number of moles, and we denote it with N, right? Number of moles. Now these are the measurable properties of a gas, and we are going to vary them. Some of them we are going to make constant, and after that we are going to vary them, and we are going to do some stuff like that to find out the 3 laws of this chapter. Now before we jump into that, let me just tell you a few things about all these 3 parameters. So I do understand that you have a basic knowledge, but still, when we talk about pressure, you know that pressure, there are so many units, and you need to be very much thorough with all the units and the values over there. Whenever you get a question, you are definitely going to find these type of things in there. So pressure is denoted in atms, right? So if I talk about normal temperature and pressure, that would be 1 atm. Now 1 atm can also be written as 1.013 bar. So that's a very accurate value. So you can just take it as 1, because 1 atm and 1 bar, they are just the same, isn't it, over there? So it's like a very minute difference in between them. So sometimes people say that 1 atm equals to 1 bar. That's not a big deal. Now there's another unit with respect to which you can write 76 centimeter Hg. So from where is this unit coming? So do you remember, like, when you learned that what is standard temperature and pressure? At that time you learned that the standard temperature pressure is the pressure. If I talk about the exact pressure, what is the 1 atm pressure, if someone asks you? So definitely in your lower classes you have told them like the pressure exerted by 76 centimeter mercury column is called the atmospheric pressure. So that's the same thing coming over here, 76 centimeter mercury column. Now I can also call it 760 millimeter mercury column, all the same, and this can also be called as 760 torr. So these many units you have to remember. Depending on the different types of questions, you have to convert them. Okay, these are the units of the pressure. Now I guess you know what is the pressure. So pressure of a gas is the force exerted by the gas in unit area, right? Let's say I have a container. Inside that container I'm putting the gases. Okay, I'm not putting two types of gases. In that case, what would happen if I put two types of gases? Then both of them would put the pressure and we have to add them up. So for that, we have a law called Dalton law of partial pressure. So we are going to talk about that later. Right now, you just take it as there is only one type of gas. Now these type of gases are moving randomly in all the directions because of the Brownian motions, and in because of that they're hitting the wall of the container. Now, you just magnify one of the wall of the container. If you just magnify it, let's say this is the wall. Now, in that wall, the one gas molecules would hit it and they would put some force in it. Now, this force per unit area is called the pressure. This force per unit area is called the pressure. So pressure can be, okay, one more thing I forgot to tell you. 1 atm can also be turned into Newton per meter square. Like from here you can understand that force have a unit of Newton and area have a unit of meter square. So from there, pressure can have a unit of Newton per meter square, which can also be called as Pascal. Okay, there's nothing to understand over here. You just have to remember all these things. Okay, so 1 atm equals to 10 to the power 5 Newton per meter square, which is called Pascal. Okay, 1 atm equals to 10 to the power 5 Pascal. Now, so these are all the type of units you need to remember. Now, I would go to the next part where I'll be talking about the volume. Okay, do I have to tell you anything about volume? Volume is the space occupied by the gases, right? So for the gases, wherever you put it, it would occupy the entire space. So the volume changes for a gas molecule. So I don't have to tell you anything about that. And definitely the number of moles, you have a preliminary idea. What are the number of moles, right? So volume, you have an idea. Number of moles, you have an idea. And temperature. Okay, here just remember one thing. When we talk about temperature in this chapter, that has to be in Kelvin. All the temperature have to be in Kelvin. Just remember that, right? So these are the different types of parameters. Okay, I guess you know how to convert Celsius to Kelvin, right? 273 plus T. 273 plus Celsius scale value, whatever it is. That would be the Kelvin value. I guess you remember that. So these are the different types of things that is needed. Now I just move on to the first law, which is called the Charles law. Okay, let's start with the Boyles law first. Now, what is there in the Boyles law? So according to Boyle, so how many parameters were there? How many variables? Pressure, volume, temperature, and number of moles. Okay, so first what they did is, first they made temperature and the number of mole constant. What they did is they went for making temperature and the number of moles constant. If that's constant, the relation between pressure and volume is inversely proportional, and I don't need mathematical support for that, isn't it? If pressure increases, then volume decreases, right? So let's say I have a gaseous chamber and there are gas molecules. Okay, now I have a piston on the top of it. Okay, there's a piston. So if I increase the pressure in the piston, the volume of the gas would decrease, right? So P varies 1 by V. This was given by Boyle. Okay, one more thing, just remember, temperature and the number of moles is constant. Now from there, he has written like, then PV equals to constant. PV equals to constant. From there you can write P1 V1 equals to P2V2 equals to P3V3. Okay, so P1 V1 is constant. So if you change the pressure, then the volume would definitely change, but the entire multiplication would remain the same. That's what they're saying over here. Understood? Now, now this was the Boyle's law. Now from Boyle's law, what type of question can they ask you? So right now, for the time being, just remember this curve. Okay, if this is P, then the curve would look like this. Okay, this is the PV curve. Now, a simple question. Let's say I have a point A over here and I have another point B over here. Now you need to tell me what is the temperature of A and what is the temperature of B. Means which temperature is greater, temperature of A or the temperature of B. Again, there's a PV curve, there's a curve we can see. In that curve there are two spots A and B. Okay, in which spot the temperature is more, the spot A or the spot B? That's the question. So pause the video and think about it, and then play the video with your opinions. Now, the point is the answer is going to be the temperature of A is equals to the temperature of B. The temperature of A is equal to the temperature of B. Now, why is it happening? Because if you remember, I told you this is the curve of P varies 1 by V, right? So, in here, what happens is this is the Charles law. This is the Boyle's law. In the Boyle's law, we have already seen that we are going to put the in Boyle's law, we are going to put the temperature and the number of moles constant, right? So throughout the curve, the temperature is constant. So as throughout the curve, I'm already saying the temperature is constant. So the temperature of A and the temperature of B is going to be the stronger, going to be the same, right? So that's why TA equals to TB. That's why as throughout the curve, the temperature remains constant. So because of that, we call these type of slopes as isotherms. We call it isotherms. Okay, this is the thing. Now, so this is the isotherm is being obtained in the Boyle's law. So I am not going deeper down into the different types of questions, but all I'm going to tell you is, let's say I have another curve. Okay. Now, if I draw the same curve one more time and one more curve. Now, for this curve, the temperature is T1, and for this curve, the temperature is T2. Now, you have to tell me whether T1 is greater than T2 or T2 is greater than T1. So, relation between T1 and T2. Okay, I guess you have thought about it. Now, look into it. The thing is, the answer is going to be T2 is greater than T1. Okay, when the temperature is increasing, the pressure is increased. Because of the pressure is getting increased, the graph would go shift into the higher region. Okay, so that's the Boyle's law. Now we would move on to the Charles law. So I'm just giving you an overview of all these laws. Okay, we'll be solving question in the next video. There we'll be going a bit deeper, and we are going to see that what type of questions are going to be asked from him. So now the next topic is the Charles law, and now we are going to talk about the Charles law. Okay, in the Boyle's law, what we did is we have made P and V variable, right? We have made P and V variable, and the N and the T were constant. But here what we are going to do is we are going to do the opposite thing. So here what are we going to do? In the Charles law, we are going to make V and T variable. Okay. So V and T is variable. V and T. Now, definitely in the Charles law, P and N, both of them are constant. Okay. Now, how would the curve look like? First, let's see what is Charles law trying to tell you. Let's say I have a beaker. Okay, I have a beaker. Now, what I did is, in that beaker, I took some gas particles inside it. Okay, some gas particles are there inside this beaker. Now, the point is, I am heating this beaker from here. Okay. When I saw the temperature has increased by 1 degree centigrade, when I saw the temperature has increased by 1 degree centigrade, at the same time, I can see that, look, with increasing temperature, the volume is definitely going to increase, right? So this is the thing. So when I increased the temperature, the new volume got changed. New volume got changed. So that's why we can say the volume is proportional to temperature. So like when you increase the temperature, the volume is increasing. That's right. But by how much? That also was counted by Charles. So it is increasing, let's say at 0 degree centigrade, when the gas was at 0 degree centigrade, then the volume of that gas is called V naught or V0. Okay. Now the point is, if I increase the temperature by 1 degree centigrade, then the amount which is getting increased is V0 by 273. Okay, that is the amount of volume which has been increased. Understood? So V0 by 273, by that amount it is increasing. Now we can say, volume of a gas at any temperature can be written as V0 initial temperature. So like, what is the total volume of the gas right now? So at 1 degree centigrade, there was some temperature. At 1 degree centigrade, there was some value of volume. So let's say that was, okay, let's start with this. Let's just say like that. At 0 degree centigrade, the volume was V0, right? And now when we increase the temperature to 1 degree centigrade, when I increase the temperature to 1 degree centigrade, there the volume is getting increased by this much. So what is the total volume? V naught plus V naught by 273. Okay. This is how is it getting formed. Okay. Now for 1 degree centigrade, the change was of 1 degree centigrade. That's why it is V naught by 273. Let's say the temperature is getting increased by 2 times. Then it would be 2 V naught by 273. তাই তো 2 V naught by 273. তার মানে what I mean is, like right now, if I increase the temperature by 3 degrees centigrade, so it would be 3 V naught by 273. If I increase the temperature by 4 degrees centigrade, then it would be 4 V naught by 273. What I meant is, if I increase the temperature by T degrees centigrade, then the volume would increase by V0 T by 273. So this is the Charles law. So this is the mathematical expression of Charles law. Now this expression can also be written in terms of Kelvin temperature. Right now you can see the small t, which means this is the Celsius scale. So you can take it to the Kelvin scale as well. In the Kelvin scale as well, you can find out the volume. So how can you do that? So what you have to do is, Vt equals to, take a common, V naught 1 plus T by 273. Okay. Now Vt equals to V0 into 273 plus T by 273 V0. So 273 plus T. This is the value in Kelvin, isn't it? Okay. So Vt equals to V naught. Then this is the Kelvin temperature. So what I'm going to do is, I'm not going to write the same thing all over again. What I'm going to do is 273 plus T is K. I mean 273 plus T. Yeah, that is in the Kelvin scale. So that's why what I'm going to do is, in Kelvin scale we write capital T. In Kelvin scale the temperature is written as capital T, right? And otherwise it's written as small t in Celsius scale. So V0 into T by 273. Okay. So Vt equals to V0 T by 273. Okay. Now this T over here, this is in the Kelvin scale. So right now what I can tell you is, if I try to draw a curve in Kelvin scale with Vt, so it would be like, look, this is in the x-axis, you can see, look into the curve, this is in the x-axis. Now whatever is there with x, if I talk about y equals to mx plus c, so whatever is there with x, that's called m. So what is there with x over here, that's v0 by 273. So that's the slope right now. V0 by 273 is the slope. So it would be a straight line. The intercept was 0, right? The intercept was 0. Now the slope is found out. This is the slope. Okay. And the intermediate is 0. I have already started from 0. So yeah, that's the thing. So when Kelvin scale, it looks like this. But if we think about the Celsius scale, if you look into the Celsius scale, so what was the formula again? Vt equals to V0 plus V0 into T by 273. Okay, this is the expression of Vt. Now the point is, if I try to draw a curve from here, okay, Vt versus T, okay, Vt versus T, I'm trying to plot it. So now again, y equals to m into x, T is equals to x plus c. Okay, so V naught is c. There will be a straight line starting from V naught distance from the origin. Okay, plus V naught T by 273. Now, after that, it would be with T, it is x, so the rest of the portion is m. So there will be performance over there. What's going to happen is, it's going to be a straight line, and the slope of this would be V naught by 273. So that's the difference in between two curves. Okay. Now, I don't want to make this video too long, so that's why I'm going to keep it up to this. In the next video, I will be talking about the Boyles Law, and then we will be moving on to the different types of questions. So thank you for coming here, and just stick to it. I'm going to release very good videos, and over there what I'm going to do is I'm going to solve previous year questions. So those are the things that you need the most. So that's why subscribe to the channel. So, and always go and hit the like button and click the bell icon as well, so that you get all the notification whenever I'm uploading a video. So that would be it, guys, for today. Meet you soon.